After 3 failed attempts, the Army is finally testing the most powerful helicopter in the history of aviation. This revolutionary aircraft is equipped with advanced technology and a new powerful engine that promises to redefine aerial dominance and serve as a formidable replacement for the Kiowa Warrior, enhancing the Army's reconnaissance and support capabilities in future operations. However, the Army has encountered a hitch in its plan. What delay did this project recently encounter? What impact did it have on the future attack reconnaissance aircraft? Join us as we explore the capabilities of the most powerful $3 billion helicopter that the United States is currently testing. For years, the Army has tried to find the perfect replacement for the OH-58D Kiowa Warrior, a helicopter that served faithfully for decades. Unfortunately, they faced disappointment after 3 failed attempts to find a better option. But now the Army is on a fast track to success, as they expect the Future Attack Reconnaissance Aircraft, or FARA, by 2030. This new aircraft is set to revolutionize how the Army operates in the skies, giving soldiers a powerful, modern tool to tackle future challenges. The Army is working with 2 top companies, Bell and Sikorsky, to build and test competitive prototypes. These aircraft are packed with advanced technology and are designed to meet the Army's future needs. The goal is to finalize the design and ensure the new aircraft can perform all the critical missions once handled by the Kiowa Warrior. When the Army decided to retire the Kiowa back in 2013, it left a huge gap in their helicopter fleet. To fill that gap, they relied on the powerful AH-64EE Apache attack helicopter paired with unmanned drones. While this solution worked, the Army knows that a dedicated attack reconnaissance helicopter is the key to truly modernizing its forces. That's why FARA is the Army's #1 priority in helicopter modernization. Leaders believe this new aircraft will be the answer they've been searching for, a machine that's faster, smarter, and more capable than anything they've had before. Aside from the FARA, the Army has been working hard for nearly a decade on a new aircraft called the Future Long-Range Assault Aircraft, or FLRAA. This aircraft is expected to debut around the same time as the Future Attack Reconnaissance Aircraft. To make sure the FLRAA project stays on track, the Army has spent years testing technology demonstrators, which are special prototype aircraft designed to reduce risk and ensure success. These tests help identify any issues early on, giving engineers time to fix them before moving to the next stage of development. Unlike FLRAA, the FARA program hasn't had the luxury of extra years of testing and fine-tuning. This means the FARA project faces more challenges in its development process, but the Army is confident that it will be ready in time. The companies competing to build FARA are no strangers to the Army's vertical lift modernization plans. Bell and Sikorsky Boeing, the 2 teams also working on FLRAA, are bringing their expertise and lessons learned from FLRAA to FARA. This experience gives them a unique advantage, as they understand the Army's goals and requirements for future aircraft. Brig General Rob Barry, who oversees Army aviation programs, recently gave an update on FARA's progress. He reported that both Bell and Sikorsky Boeing are advancing their designs on schedule and meeting key program goals. According to Barry, the teams have completed about 50% of the air vehicle prototype, which is a significant milestone in the project. One of the most exciting developments in the FARA program is the upcoming test of the engine that will power the aircraft, known as the Improved Turbine Engine Program. In 2019, General Electric Aviation won the $517 million contract for the engineering, manufacturing, and development phase of the Improved Turbine Engine Program, beating out the Advanced Turbine Engine Company, which is a team from Honeywell and Pratt & Whitney. General Electric's T901 engine is set to replace the T700 engine currently used in the Army's older utility and attack helicopters. It could also be used in the Army's future reconnaissance helicopter as part of the future vertical lift systems. Jim Thompson, Jr., the acting deputy director for the Army's future vertical lift cross-functional team, mentioned in a recent interview with Defense News that the requirements for the future attack reconnaissance aircraft include the ITEP engine, which has received the stamp of approval from the Future Vertical Lift Program. The ITEP engine addresses several challenges that arose while the Army operated the Apache and Black Hawk helicopters in combat in Afghanistan and Iraq. As the Army added armor and upgrades during wartime, the AH-64 and UH-60 helicopters became heavier, and they often flew in hotter conditions and at higher altitudes than what is usually considered ideal. Mike Sousa, GE's business development leader for advanced turboshaft engines, stated in December 2018 that the helicopters were originally designed to operate at 4,000 feet on a 95-degree day, but they were flying at much higher altitudes. He explained that when this occurs, the engine doesn't produce as much power. He also mentioned that the Army had clearly outlined its requirements for the improved turbine engine program, seeking a 3,000 shaft horsepower engine that would reduce fuel use by 25% and extend its service life by 20% compared to the T700, which has a power of 2,000 shaft horsepower. In August 2016, both companies received contracts to help reduce risks, with ATEC being awarded $154 million and GE Aviation getting $102 million to improve their designs. Both companies had already invested years in developing new engines and innovative technology. As the current manufacturer of the T700, GE proposed a single-spool engine design. Sousa noted that this choice would assist in meeting weight limits while keeping costs low and simplifying the design. He emphasized that their main goal was to make the engine as affordable and lightweight as possible. Ron Hutter, GE's executive director of the T901 program, added that helicopters operate in very challenging environments, often landing on unprepared surfaces and generating a lot of dust. Therefore, he said it was crucial to focus on the simplicity of the design for maintenance, which led them to choose the single-spool configuration. GE estimated that it had invested $9 billion in testing technologies related to the T901. This powerful engine will give FARA the speed and performance it needs to succeed in future missions. The first test of the engine is scheduled to take place soon, and it will provide crucial information as the Army moves forward with the program. Brigadier General Barry emphasized that the results of this engine test will give the team greater clarity and help them make important decisions as they move forward into the next stages of development. As both FARA and FRA continue to advance, the Army is working hard to ensure these new aircraft are ready to meet the challenges of the future. By combining the lessons learned from years of testing with cutting-edge technology, the Army hopes to create a fleet of helicopters that are faster, more capable, and better equipped to protect soldiers and complete missions successfully. With FARA and FRA set to come online in the near future, the future of Army aviation looks brighter than ever. Defense News asked Colonel Greg Fortier, the Army's FARA program manager, and Colonel Matt Isaacson, the FVL Chief of Operations, about how the Army is managing its requirements and schedule as they move forward with FARA. One question was about the specifications for FARA, including what the Army considers non-negotiable and where there's flexibility. Isaacson explained that the FARA prototype development started with a list of desired features outlined in the initial capabilities requirement document. These features focused on agility, speed, rotor size, engine design, weapon systems, and a modular design approach. By quickly building prototypes and analyzing early weapon system designs, the Army is aiming to efficiently develop achievable capabilities. Isaacson also mentioned that the abbreviated capabilities development document updated these original features based on information gathered during the final design risk reduction in December 2020. This document will continue to be adjusted through FY22, with the final version expected in FY23. When asked about the 40-foot rotor blade requirement and whether it might change, Isaacson explained that this size was based on studies conducted in urban environments before the ICRD was written. The final requirements will be shaped by data from the ongoing prototype builds and risk reduction processes. Isaacson explained that the final set of requirements, known as the Capabilities Development Document, was scheduled to be presented to the Army Requirements Oversight Council in FY23. Fortier mentioned that industries had been adjusting their designs as they moved into the building phase, citing Bell's decision to redesign its tail rotor as an example. He highlighted that new aviation programs typically require a lot of time in the design phase. According to him, industry had done a good job refining initial designs, incorporating the needed technical rigor and innovation to align with the Army's expectations. He anticipated further design refinements as prototypes were built and tested, noting that this fly-before-we-buy strategy would validate engineering models and save time in the future development stages. When Fortier was asked if he expected to make major changes to the design or parts during the engineering and manufacturing development phase, which could add risk to the program, he explained that the way the program is set up, developing and testing prototypes before reaching milestone B, helps lower the risks associated with EMD. By refining the weapon system design and clearly discussing options before starting the EMD phase, they can minimize schedule delays and technical issues while improving performance. He acknowledged that challenges during testing might require design adjustments, but they have a unique 3-year opportunity to understand the weapon system before it officially begins. This reduces the risk of discovering misaligned requirements late in the process and allows for cost-effective changes within the timeline. Regarding the timeline, there were worries that it might be too ambitious since the future long-range assault aircraft had 10 years for development, while FARA does not have the same time frame. Fortier recognized the concerns about the tight schedule but pointed out that the joint multi-role technology demonstration for FLRAA and the competitive prototyping for FARA are not the same because many FARA activities are happening at the same time. In just over 2 years, the FARA program has reached 8 milestones ahead of or on schedule. He shared that just 8 months earlier, they faced a challenge to demonstrate the firing of air-launched effects from a launcher that was not yet built, and to fire the XM915 20mm gun from a substitute UH-60 at Project Convergence in October 2021. He was pleased to report they are on track to meet the next 2 milestones as well. This progress is due to excellent teamwork among various groups, including PEO Aviation, the Future Vertical Lift Cross-Functional Team, Army Contracting Command, and the Combat Capabilities Development Center at Redstone Arsenal in Fort Eustis. He noted that FY22 and FY23 are critical years for the program, as they will finalize analyses, release a request for EMD proposals, complete the initial design review, and move forward with prototype flights. In 2020, when an unexpected delay on the new engine technology was announced, the U.S. Army still proceeded with developing systems for its future attack reconnaissance aircraft. However, the FARA project is now delayed, with prototype test flights expected in the last quarter of fiscal year 2024 instead of late 2023, as earlier revealed. Both competitors, Bell and Sikorsky, have already built their prototypes but are waiting for the new engine to complete them. Despite the delay, the Army aims to keep advancing the FARA system, including features beyond just the airframe, while working around the engine delays. Major General Wally Rugen shared that the Army has already gathered a large amount of data from the Future Attack Reconnaissance Aircraft program. He acknowledged that everyone is eager to see the engines fired up and the aircraft take flight, but explained that they are working with both a developmental engine and aircraft at the same time, which makes things more complex. Unlike the Future Long-Range Assault Aircraft program, where Bell was selected after years of testing, FARA has a tougher technical challenge. Rugen mentioned that while the engine is causing delays, it's necessary to ensure the aircraft has advanced capabilities like better fuel efficiency and more power. He also noted that a recent engine test reached 3,100 shaft horsepower, highlighting the power the new engine will bring. What led to the unexpected delay of the ITEP engine? General Electric faced significant challenges with its ITEP engine due to the COVID-19 pandemic. According to Major General Rugen, the company struggled not only because of issues with sub-suppliers, but also lost experienced technical staff, including engineers and quality control managers. He explained that this combination of talent loss and supply chain disruption created a tough situation for GE. While he acknowledged that the company was overcoming these problems, he wasn't completely satisfied, but recognized that the focus was now on how to maintain progress. Army Acquisition Chief Doug Bush mentioned that recent ITEP delays were mainly due to quality control issues with some sub-tier vendors, particularly related to new components and manufacturing techniques like 3D printing. He also revealed that the company believes the program is now under control, and his team of experts thinks the current estimates are reasonable, though there has been a delay. He also noted that the Army is conducting an analysis of alternatives for the FARA program, which is slowing things down. The technology won't reach the maturation phase until the first quarter of fiscal year 2026. According to the FY24 budget documents, the Army plans to finish the engineering and manufacturing development for ITEP by the third quarter of FY26, with initial operational capability expected by the third quarter of FY29. This marks a nearly 2-year delay compared to the FY23 timeline. While waiting for the engine, the Army is working on developing weapon systems and a modular open system architecture for the aircraft. This effort aims to recover lost time and scope in the program. The Army is also sharing draft design requirements with the industry and taking steps to reduce risks during development. The modular open system architecture will host mission systems like survival equipment and the modular effects launcher. This system allows the Army to easily integrate new technology when it's ready. Other branches like Special Operations Command and the Marine Corps are also adopting the modular effects launcher. The focus is on making FARA a deep sensing platform capable of seeing farther and using a range of effects like missiles, rockets, or electronic warfare to strike threats from greater distances. The mission systems architecture for the future attack reconnaissance aircraft is designed to connect soldiers and sensors on the battlefield using a strong aerial tier network. This system aims to create better communication and data sharing during missions. The Army Requirements Oversight Council is expected to decide by the end of the year whether to continue developing this network as part of the FARA program. The Army has already tested elements of the architecture through experimentation exercises like Project Convergence, which explores how various technologies can work together on the battlefield, and EDGE, an event focused specifically on testing aerial technologies. EDGE has been an important part of the Army's efforts to enhance aerial connectivity and capabilities and will enter its 3rd year in May. The aerial tier network is essential for advancing the Army's ability to coordinate between ground forces and airborne assets. With each experiment and event, the Army collects valuable data that can help refine the mission systems architecture, ultimately ensuring that it can adapt to emerging technologies and battlefield needs. This system will allow the Army to quickly integrate new technology when it's ready, further enhancing the capabilities of the FARA and other aircraft in the fleet. In an unexpected turn of events, the U.S. Army announced that it has decided to end its recent effort to develop the future attack reconnaissance aircraft. This decision is a major shift, marking one of the most significant program cancellations in the last decade. The Army had already invested at least $2 billion in the program and requested an additional $5 billion for the next 5 years, according to budget records. Besides canceling the FARA program, the Army also announced plans to retire its entire fleet of Shadow and Raven unmanned aircraft. Doug Bush, the Army's acquisition chief, further revealed that the Army will stop equipping the National Guard with the new UH-60 Victor model Blackhawks. Instead, the Guard will receive the UH-60 Mike model, which is the latest variant currently in use by the active duty Army forces. The U.S. Army has also announced a significant shift in its aviation plans, which includes delaying the procurement of its next-generation helicopter engine. It will instead allocate the freed-up funds to enhance Blackhawks, the new CH-47F Block II Chinook cargo helicopter, the future long-range assault aircraft, and improve its unmanned aerial reconnaissance capabilities. General James Rainey, an acquisition leader, stated that he does not view the cancellation of FARA as a failure, emphasizing that the Army is making significant progress in its modernization efforts, with most of its major programs either on schedule or ahead of schedule. In terms of ongoing programs, the Army is advancing the Future Long-Range Assault Aircraft Initiative, with Bell Textron contracted to deliver its V-280 tiltrotor aircraft. Despite doubts about managing 2 major aircraft programs simultaneously, Army officials stress that modernization remains critical. The Army also plans to invest in reconnaissance unmanned aerial systems to enhance its capabilities for high-end combat. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.